What's up, guys? I bet you're super psyched to learn about Theorem 7.5 and Theorem 7.6. Let's start with Theorem 7.5. It is the parallelogram consecutive angles theorem. Super awesome theorem. What it says is if our quadrilateral is a parallelogram, and I cannot stress that enough, it must be a parallelogram for you to use this theorem. So make sure it's a parallelogram. It's either going to tell you it's a parallelogram, or you might need to find, like, hey, if the slope of this and this line are the same, and the slopes of this and this line are the same, it must be a parallelogram, right? There's lots of different ways to prove something's a parallelogram, but as long as you know you have a parallelogram, we can say for sure that x plus y, so any consecutive angles that are next to each other, so it could be these angles, could be these angles, could even be this angle, and so I can show with another color, this angle and this angle. Any angles that are next to each other, any x plus y in this situation, must sum to 180 degrees. Okay, that should make a lot of sense. We've done this with coordinate planes, right? But basically all we have is one acute angle and the other angle. Here, this obtuse angle, if we're looking at this, we could just draw this way, so that this angle plus this angle must be a flat line, must equal 180 degrees. Alright, so that's our first theorem. Let's scroll over to Theorem 7.6. This is the parallelogram diagonals theorem. And what this theorem says is that if we draw a diagonal, so in this case from Q to S, or and also from R to P, so we have two diagonals. It's kind of a squirrely diagonal there, but you see what I'm saying. You got two diagonals, they're going to cross at some point, and we'll call that point M. Now what's interesting, when we have a parallelogram, we know for sure that this length, Q to M, must be equal to this length, M to S. And vice versa with our other diagonal. The length from P to M must be equal to the length from M to R. That's just something that holds true for all parallelograms no matter what. So let's see when we could ever use this information, these theorems. Example problem 1. Here we go. So looking at example problem 1, we see a ton of angles, right? So hopefully you're thinking red flag, probably going to want a consecutive angles theorem for parallelograms. So we scroll over, and we're looking at our consecutive angles. Now the first thing that jumps out to me is that two of our angles share the same variable. We have a B angle and another B angle. Those are probably going to be your best bet for combining right off the bat. We could add B plus 10 plus C equals 180 degrees, or D plus C equals 180 degrees. We can write that down. That's not incorrect, that's correct. But hopefully you guys see that in this situation we have two variables and one equation, which means we won't be able to solve for the actual angle. We could solve for D in terms of C, but that's not going to do us a ton of good right off the bat. So what I would like to do right off the bat is to solve for these two consecutive angles, our B angles together. So let's start like that. B minus 10, these are degrees, these are angles, degrees, plus B plus 10 degrees, plus 10 degrees, must equal, again, 180 degrees by that parallelogram consecutive angles theorem, or Theorem 7.5. So if we add these up, combine like terms, B plus B is 2B, and negative 10 plus 10 is 0, so we have 2B plus 0 equals 180 degrees. Divide both sides by 2 to solve for B, so divide by 2, divide by 2. We should be left with B equals 90 degrees. Now be careful, it's an easy mistake to make. I actually just made it and had to refilm this whole video. The angle is not 90 degrees, B is 90 degrees. So that means that this angle is 90 minus 10, or 80 degrees. So this angle must be 80 degrees. And this is B plus 10, so 90 plus 10, this angle must be 100 degrees. Now, we could go and use the same theorem to solve for other ones, but what else do we know about parallelograms? We know from, I believe it's Theorem 7.2, it's either 7.2 or 7.1, but we know that the opposite angles inside of a parallelogram must be equal. So I know if this is 80 degrees, that C must also be 80 degrees. I know that D, because it's opposite of this 100-degree angle, must also be 100 degrees. A great way to check yourself here is to add them all up. They should sum to 360 degrees. Now let's move over to our example problem number 2. And this problem, hopefully, ding, 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 should be 7.6 is the theorem we're looking for. We're looking for that theorem about diagonals and relationships between diagonals in a parallelogram. And so we look at this, we know that because this thing is a parallelogram, and I should point out that these problems should say, this thing below us is a parallelogram. I'll write that. This is a parallelogram. I'll say it like a caveman, though. This parallelogram. I can't even write it. It's such a long word. I think you get the idea. This is a parallelogram. Okay, so that it has to be stated somewhere. We must know this is a parallelogram, okay? And because it's a parallelogram, and using that diagonals theorem, 7.6, we can set these two side lengths equal to each other. And of course, these two as well. So let's start with this first one. 6 equals V over 3. And our other equation should be 2u plus 2 equals 5u minus 10. So if you're confused at all about where this stuff's coming from, go back in the video and make sure you're understanding what that theorem 7.6 is telling us. But it's basically all it's saying is that because we know it's a parallelogram and because we have two diagonals drawn, we can say safely that this length right here must be equal to this length right here. And that's what we just wrote. Now just doing a little bit of algebra. I'm going to subtract 2u from both sides on this one. So we're left with 2 equals 3u minus 10. I'm going to add 10 to both sides. So I'm left with 12 equals 3u. And divide both sides by 3. U equals 4. Okay, and then we can plug that in to get our actual lengths here. And then same thing for this one. If we want to solve for v, just going to multiply both sides by 3. And we're left with v equals 18, or 18 equals v. Alright, I hope that was helpful. That was Theorem 7.5 and 7.6, learning all sorts of things about parallelograms. Have a wonderful rest of your night.